we're going to focus on the API that'll make this possible, which is called the Web Audio API. It's a great API that's just a high-level JavaScript API that's built in to the browser. So it's not something you need to like import or deal with that kind of extra work. Your browser will be able to recognize the functions from all the APIs that you use. So we're going to deep dive into a few concepts along the way. And something to note is this will be happening on a Mac. So just the command line, a few of the command line commands are going to be a little different, but we're not really going to be in the terminal too much today. So I'm going to share my screen, kind of get started on this. All right, so here is, so I just have some slides to talk about, the whole process and just kind of like abstract each step and then we'll dive into each thing. So why am I calling it a web app? Why am I not calling it a website? Websites are probably the more familiar thing. It's kind of like a site that has one-way informational feeds. So there's not really much interaction between the user and the website. There's not really any state that's being saved, like from user action. Whereas a web app is a website with functionality and interactive elements. So like e-commerce sites are apps technically, but they're hosted on websites and they have their interface being the website. So what we're going to be building today is more of a web app because it actually takes user input and does some sort of function, and it's not just a information feed. So the actual things we're going to do today, we're going to set up our local environment, develop the UI or the user interface, because we need to be able to interact with this pitch tracking technology. And we're going to code this pitch tracking functionality with this web audio API I mentioned earlier. And styling our web app further and hosting our app are things that we might get to today, but I also think that you guys could, expand upon that later because, everyone has preferences on styling and a lot of people have their own, hosting, means of hosting and preferences on their own. So now we're going to basically just, so basically styling our web app further and hosting our app, you can do on your own. And the tools we're going to use today are command line, Visual Studio Code for the actual coding of this, HTML to develop the UI, CSS also to develop the UI, and of course you'll use it to style the web app further. JavaScript to develop the UI, doing like event listening on buttons for user input, and then also for the actual coding of the pitch tracking functionality. And we're going to be using the web audio API, as I've said, as well as another API called the Media Devices API. And we'll be using this to access our microphone on our computer. And then here's just a few concepts we'll encounter along the way. And it's like a really simple, this isn't a single page app with, React or Vue or kind of like a JavaScript framework or anything, but we're still going to be encountering, complex concepts like asynchronous behavior or promises in JavaScript. We're going to be handling button toggling state and just kind of figuring out the best way to do that with JavaScript. And then we're also going to consider this whole, like, maybe you could even call it a philosophical debate about whether to make your functions and encode everything in-house and when to borrow from our open source community. This is specific for every single person's situation and their problem that they're interacting with. And we're going to kind of talk about why we've chosen to use third-party functions instead of writing them ourselves for some of the functions that we're going to write today. And we're also going to deal with animation frames, or repetitive UI updating, and a means of doing that, and event listening and error handling. So it's a lot of stuff, and all of these concepts are, you know, the more you do every single one of these, the better you get. So whenever they're applied to a specific problem, I feel like you learn a little bit more about them each time you use them. All right. Any questions about that, or like any concepts, you know, any questions about the actual names of these concepts? No? All right. Okay, so now we're going to move on to setting up our local environment, which is going to be pretty simple. Here's, can you see everybody can see the terminal and the VS Code. I'm just in my desktop right now. I'm CDing into it. And I'm gonna make a folder. So make dir called pitch track. This is gonna be the folder that is gonna contain my app. I'm gonna go ahead and go inside of it and list all the elements in it. There's nothing in there. We're going to create an index HTML file. And we're also going to create a folder called JS to keep all of our JavaScript files in. And then we're going to go inside of the JS folder and create our pitch track JS file, which index.html will reference. And that's it. So this is our app right here, index.html, and then we have this JavaScript folder, which has the pitch track in it. So that's the extent to which, I mean, almost the extent to which I'm going to use the terminal. And we're going to go ahead and open up this project that we just created in VS Code. So I'm in my desktop pitch track. And here's our structure, index and pitch track. If you haven't used VS Code before, it's just really popular. A lot of people like it. I use Terminal. I use Vim for all of my coding, but I am considering the switch to VS Code. And that says a lot because I've been using Vim for a while and I'm a freak for Vim. There's just so much you can do with it. Maybe that'll be another workshop someday. So I'm just gonna double click on each file so that they actually both pop out. And I'm gonna actually, since I'm in terminal over here, I'm gonna open up this, open up my index.html file in Chrome. So open index.html, should bring this up in Chrome. Why did I not do that? Do it twice maybe? Yeah, okay. So it's got nothing in it. We haven't written any code yet, but we've got our local environment set up. So we can refresh this whenever there's changes. So, oh, where's I think I lost my slides. Maybe. Oh, I see. Okay, so now, anybody have any questions about this local environment setup? Sorry if this is all, you know, too slow or too fast. Any questions? Okay, so we're gonna move on to developing the UI. So now we're gonna go into our VS Code and kind of begin, you know, this really, really basic HTML file. So we're gonna get our HTML tag, our head tag, our body tag. We're going to give this a title called pitch tracking app. And something we're also going to do is we're going to set the viewport so that this app looks good on our phones. It's going to be really simple, the UI, so we're not really going to need to delve into any kind of responsive design. But this annoying meta tag that you kind of just have to memorize is the key to making things look pretty okay on your phone without doing so much work. And if we want to host our app later, I'm going to go ahead and make a description meta tag so that when it comes up in Google search results, we'll have a little explanation about what the app does. Your voice and tells you your pitch. Be straightforward. Okay, actually, let me go ahead and make this go away so that this can be big. Okay. All right. So so we're gonna have a button that, you know, we gotta have a button that says enable microphone. This is gonna be our app's access point. So considering that, I'm gonna give it an ID because I think we're gonna be hooking in to this HTML element via JavaScript to actually, you know, start the microphone process, start the pitch tracking, and so on and so forth. Also get an H1 going, pitch tracker. And we're also going to need a div that tells us our actual note. So this is going to be something like C#, D, E, F, etc. Right? And maybe just since we know we're going to have it, we'll also just drop in the actual frequency in hertz. So, you know, if you're a real baller, this will say, you know, 440 hertz. But if you're not a baller, like most of us, we're gonna have like a little detune element, which basically will tell us how off we are from like pitch perfect MIDI note translation to frequency. So this will be in sense, and we'll talk about that later. And we'll also, you know, to translate this detune, we kind of really just want to know if we're flat or sharp when we're singing, right? And kind of like getting that up to, you know, being more in tune. So this warning is probably going to say something a little bit more intelligible, like flat or sharp. So this is pretty much our HTML. It looks really bad right now. At least we can maybe center it and maybe make this pitch, this actual MIDI note, the thing we care about, a lot bigger. The thing I really like is Flexbox. So I'm going to, also I'm using a style tag because, and not linking out to a separate style sheet. You'd probably normally see, you know, rel style sheet, et cetera, et cetera, et cetera. But we're not really going to have too much style just for the time being, but you can totally expand this and make your own style sheet and go crazy. So I'm going to display this body flex. Flexbox is an amazing grid like layout tool that's built into the browser. It's a CSS tool, and you can say really human sentences like align item center, or like justify content within the item that you're centering to center, which is really, really helpful. And it's also the only, it's actually probably the best tool for vertically centering elements. So you'll notice that this is not only horizontally centered, but vertically centered. And that's what's so cool about it. The thing we need to fix now is just all these elements are just smushed up against each other. And it's because Flexbox is trying to align every single item in the body, because I've referenced this rules, referencing the body. It's trying to put every single item in the center here. So what I'm gonna do is I'm gonna make a container that just sits around this guy. Also VS Code thing, you can Option Shift F and it formats for you, which is really nice. Vim doesn't. Well, actually, maybe Vim has that, but I haven't messed with that. So now our container is the thing that's being centered now. It's now saying, just Flexbox is like, okay, everything that's in the body, and there looks like there's only one thing in this body, we're going to center this thing. So it actually obeys us a little bit more. And we're probably going to want to center this to make it look nice. So now it's centered. And the last style thing I'll do is this actual note, the thing that we care about the most. I'm going to make it really big. So this is the most styling that I'll do, or maybe so far in this workshop. Pretty simple, because we're going to focus on the JavaScript more. Let's see. So we've in essence developed the UI. Now we're gonna stop live coding for a moment just to talk about the web audio API and, you know, how we're gonna, you know, pseudocode this out and just figure out the steps that we need to do by diving into this API more and seeing how it works. But before I move on, any questions about the development of the UI? Okay. All right, so as I said before, this is a high-level JavaScript API for processing and synthesizing audio and web applications. The web audio API is actually part of this entire, it's library of web APIs, copy link address, or maybe I already have it up. Yeah, I do. There's a large number of web APIs available. The web audio API is just part of this entire ecosystem of APIs that the browser has access to. So these are libraries you don't need to import. They're built in, which is really great because you can do a lot of stuff with a lot of these APIs. The API we're going to be using is right here. So all the documentation is here. All the functions we're going to use, we can just refer to right here and see how to use it. And we're going to talk about this workflow right now. So the web audio API typical kind of workflow is you create a audio input and you also have an audio destination, and you have to connect the two within an audio context. So the audio context is kind of like the gateway into this whole thing. The reason why you would use the web audio API is usually because you'd want to put some sort of manipulation in between that audio input and the audio output. Like you want to put a panner, or you want to bump up the gain, or you want to filter something, or you want to put on like a reverb effect, or you want to do analyzing, which is what we're going to do. Audio inputs, modification of audio and output. And we'll see what that looks like in code soon enough. So just written out, just writing it out in case you're not a visual learner. We create the audio context. Inside the context, we create sources, input sources, such as, if any of you have seen the audio tag, that is an HTML element that can play audio files, any kind of audio, most kinds of audio files, depending on your browser. We can even create oscillators with the web audio API, and then stream is the last one. This is an audio stream of some kind, and we're gonna use our microphone stream. And then this is a typical workflow: creating effects nodes, choosing the final destination of the audio, for example, your system speakers, and then connecting the sources up to the effects and the effects to the destination. So, you know, you got to create this source, you got to create this node, you got to create this destination, and then you got to actually hook everything up along with creating the audio context. So these are the steps, and they're all translatable in code. And we're gonna do that. Our workflow is really similar, but it's slightly different. We're gonna create the audio context. just the same. Inside the context, create the source. That source is going to be our microphone stream. We're going to create effects nodes. Oh, we're not going to do this actually. We're not actually going to make an effects node, but we are going to, create an analyzer node in between the input and the output to determine the pitch of the microphone stream. And that's it. Those are our steps. So any questions about that so far? That's pretty theoretical, but anybody got any questions? Okay. All right, so we'll move on and go back to the live coding to actually do our third and final step, really, which you'll notice have a lot more steps in it. So our pitch track JS file is just sitting over here, and we need to reference this. So JS pitch track JS. So now when we go into our browser, we've got access to this pitch track JS file. And now we're going to need to hook into our HTML. So I'm going to grab this enable mic element by ID. Get element by ID, enable mic. Since this is a constant thing that's not going to change, I'm going to have it be a constant. Enable mic button. And this enable mic button is presumably going to enable the mic. So I'm going to set its event handler for the event click to a function called main, which I haven't written yet. I'm hooked up to enable mic button. Let's just make sure this is all working. Always testing along the way. Okay, and it looks like we're good. I'm hooked up to enable mic button. So there's something that we need to handle here, and that is, well, we'll write out all the pseudocode first of what we're going to do. But there's something that we need to know, which is basically the state of the app. Is the app tracking you right now, or is it not? It sounds kind of sketchy, but we need a way of turning on and off our mic. And I'd go ahead and say that if the mic's turned on, we're pitch tracking. And if the mic is turned off, we're not pitch tracking, right? So we're going to need to, what's the state of the app? Determine that. If the state is to pitch track, I'll say. If the state is to pitch track, then we want to turn the microphone on and begin tracking. And then we'll want to make the enable mic button say disable mic, right? Because we want to actually toggle that state after we're done doing the job. So if the state isn't to pitch track, so if the state is to not track, then we want to end the microphone stream, and we want the enable mic button to say enable mic, right? Because if we're disabling it, then we want it to say enable again, so somebody can enable it. Again, we're going to be toggling the state there. So this is roughly our path so far. So right now I'm going to try to get the state of the app, and the best way to do that, in my opinion, is to use data attributes. So data tracking would be like, if you're tracking, it's true. If you're not tracking, it's false. If this button says enable microphone, that means we're not tracking. Tracking is going to be equal to false. So there's a great, oh wait, we need to get this attribute. So we can use enable mic button dot get attribute data tracking. So this in and of itself, actually we can try this right now in the browser. So data tracking is false right here. If I go ahead and copy and paste this in the console, we actually get a string that says false. We want to actually convert that to a Boolean because it'll just be like way cleaner for us to deal with the state. So we can go ahead and say equals 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 true. And then suddenly we have a Boolean, right? So let is tracking equal, if the data tracking says true, then that means is tracking is true. So now we've gotten the state of the app. What we need to do is when you click on the button, we need to toggle the state, right? We need user, you know, the reflection of us clicking the button. So I'm going to actually set this attribute data tracking to the opposite of what is tracking equals. So let's see that in action. So notice data tracking is false. When I enable the microphone, it says true. And I click it again, it says false. Obviously, we haven't done this inner HTML update yet, but we will. This is the kind of first step to that. So now we have successfully gotten a way to save and toggle state. So now we can move on to like the rest of this pseudocode. So if the state, which is tracking, is to pitch track, so if is tracking is true, and notice I use equals equals equals, which is not just is this object equal to this other object, it's is this object equal to the other object and also the same type. We've ensured that this is going to be a Boolean over here, so we're good on that front. So if is tracking is equal to true, then do these things. Turn the microphone on, begin tracking, etc., etc. Otherwise, if the state is not to track, then we want to do these things. So at this point in time, I'm kind of like, well, if you're going to click the button, I feel like I'd want to see something that says that it's working, right? Enabling, perhaps. Because we actually don't know how long this is going to take. We don't know how long it's going to take to turn on the microphone. We don't know how long it's going to take to set up the analyzer nodes and do the pitch tracking. So we want some sort of buffer time in between the mic getting enabled, you know, and it not being enabled. So we also want to end up disabling the mic or saying that it's disabled in the same manner we did this. But I just want to test this enabling code real quick. Okay, great. So data tracking is false, which it hasn't gotten to be true yet, and it's enabling, but we still need to finish actually doing the enabling and then setting it to disable. So I'm going to go ahead and actually code this part because it's, you know, we already know how to do it. Inner HTML, disable microphone. And since this is pretty much the exact same, I'm going to do the same thing, enable microphone. So now we have it, oh, is tracking. So if is tracking is true, yeah, then disable microphone. If it's not tracking. So if the actual, sorry, I totally reversed this. If the actual app is not tracking currently, then we want to track, right? So if the state of the app is tracking or is not tracking, then pitch track, right? and then otherwise end the microphone stream because we're clearly trying to disable this thing. Sorry, that was kind of confusing. All right, so now we have something that enables and disables, and our state is aligning now with the actual HTML. So now we can kind of move on from the toggling state. Does anyone have any questions about the toggling state and how we've handled it? All right. So we're gonna move on to this part, which we haven't done. We haven't done this one yet either. So turn on the microphone and begin tracking. So we're gonna create a function called getMicrophoneStream. GetMicrophoneStream. It's gonna get our, when I say stream, it's this term that basically just means this influx of audio information. It's constantly coming. It's a stream. So we're going to use the media devices API to actually get this stream. So media devices.get user media is exactly what we're going to be using. So it prompts the user for permission to use a media input, which produces a media stream with tracks containing the requested type of media. We're going to request audio. You could request video as well. But we wouldn't, you could also pitch track your video and then like make some cool beats over that and call it a day also. Like there's so many things you can, you can do. You can pitch track the wrong things if you'd like, it's all up to you. So the way to do it, the way to actually get this media is to either use this means of writing this function or this one. This is an asynchronous function. We talked about how we were gonna maybe use asynchronous functions or promises. And this is the kind of the raw promises way to actually code this. So we basically need to find out what is this constraints thing that we're passing in. So it's either audio true, video true. You can get both, or you can get one or the other. We're going to get just the audio one. So let's go ahead and copy this code because this navigator, remember, it's all built into the browser. You don't need to import any libraries, which is cool. And we're just going to paste that on in here. I'm going to format this. So we also need to know what constraints are. We found an example of constraints right here. I'd say I would make this a constant down here because it's unlikely to change. And I'll call it constraints. Make it a global variable. And change video to false. Also, I'm just going to go ahead and dub this section as the variable section. So now we can test this code to see if we've really gotten this stream. Console.log got microphone stream. And then we also want to say, did not get microphone stream if that error's out. So, okay, if it's not tracking, then get the microphone stream. Let's see what happens. All right, now we've basically gotten to the place where it says prompts the user for permission. I click allow, and it looks like it's listening to me now. Can you see this little dot here? And we got our got microphone stream console log. I'm gonna go ahead and disable it. But see, what I really want to happen when I hit disable is I want this thing to stop listening to me because that's invasive. So we have to handle the whole stop stream function. We got it successfully, and now we're basically going to move on and implement this step, which is, if you'd like it to not stop tracking, then we want to end the microphone stream. So I'm going to write a function called stop microphone stream, and we're going to figure out how to do that.
Hey, Monica.
Yeah.
Do you want to take a quick break and just kind of run through the code, just like do a quick review of what we have so far?
Yeah,
Just to make sure that everybody's on the same page.
totally, totally. So far we've created a UI with just a basic title and then 2 meta tags, a little bit of styling just on the general body, and a container element, an H1, a button, and the place in which we're going to drop all of our analyzed pitch information that we're going to get from our JavaScript file. So we are actually including this script that is going to do the pitch tracking at the bottom of the body. We've also, a little bit more of an advanced, HTML topic is we've started to use the actual data attribute. Data is great because it's kind of like each HTML element will have like attribute and attributes object to it, and prepending the name of the thing that you want to grab with data will make that come in here. So we can have, data tracking false will end up being in here. Data whatever will be anything you want, right? So it's kind of a really nice way of like accessing and stuffing information into HTML elements. So that's what we've kind of done here, and just put IDs on everything so that we can access them with the JavaScript function get element by ID. So just overviewing this file so far, what we've done is we've made we've assigned a function to this event listener for this enable mic button. And I would go ahead and say this is the start of the world. You're always kind of like looking for the start of the world for any kind of app or web app. And that's where it is, because as soon as the user clicks on that, then we get the ball rolling and we try to turn on or off the microphone and do the pitch tracking if that's the state of the button. So what we've had to do is what I talked about with the data tracking attribute. We're now saving the state of the button in this attribute and grabbing it, setting it to its opposite, meaning toggling the actual state. And if the state of our app is not doing any pitch tracking, then that means let's go ahead and do the pitch tracking. So I'm setting the inner HTML to enabling, just because I don't know how long it's going to take to end up turning the microphone on. So let's just set that to something in the meantime. And we have this function get microphone stream, which is we just wrote up here, and it pretty much contains the exact code from the media devices API, which is the way to ask the user's permission to get a microphone stream going. And this is the function that deals with, so this is a promise. If we've successfully gotten the stream, then here's the code block that basically says, yay, we got the stream. We have access to the stream. We can do what we wish with the stream at this point. And this error code block, basically, if this for some reason fails, like if the user says, no, I don't want you to use my microphone, then it's going to enter into this catch block. And we're going to need to handle the error. And so that's kind of where we've gotten so far. Pretty much just getting the microphone stream successfully and setting the state of the buttons, and having the actual HTML reflect that state. So yes, any questions about that so far from anyone? Okay, so I'd say we can move on to, well, actually, I'd like to actually test this scenario, you know? I feel like if something went wrong getting the stream, I would want to know like immediately instead of just a little console log. So we're going to actually pop up an alert and maybe say a nicer sentence like turning on microphone was blocked. So let's test that. Enable microphone. I'm going to block it. And we got our alert saying turning on microphone was blocked. And at this point, take a look at the state right now of this. Disable microphone. We want to actually make that say enable afterwards because maybe the user wants to try again. So I'd say at this point, I would just grab that enable mic button variable that we've saved and make this say enable microphone once again. So yeah, now we can block it and it's back to normal. So what we need now to deal with is actually making this thing stop listening to us. So we're going to write a function called stop microphone stream, and we're going to find out, you know, how are we actually going to stop this stream? Well, let's take a look at the actual stream itself to see what it even is, right? I'm going to allow. It looks like it's printed a media stream object. So media stream is, I think we could probably find what media stream is. Yes, so the media devices API also produces this media stream. It says it contains tracks containing the requested type of media. We requested an audio track. So it represents a stream of media content, et cetera, et cetera. The stream consists of several tracks, such as a video or audio track. Each track is specified as an instance of media stream track. So if we wanted to take a deeper look, let's just take a look at some of these functions. Because maybe we can stop the stream just by looking at what methods are available to us. It doesn't seem like there's actually a stop stream function, but there is a function called get tracks or get audio tracks. Either one would probably work, where we can get all the tracks and actually stop them ourselves. So let's actually just use that in the browser because we can't. So I printed this stream earlier, and I'm going to go ahead and right click on it and click store as global variable, just so I can mess around with this thing. All right, so it's called temp1. temp1.get tracks. Looks like an array of media stream tracks, as the documentation said. And we've got this one media stream track object. The type is audio, has an ID, and the label is my MacBook Pro microphone built in. So now we can kind of see like this actual track object that we need to stop, right?
Hey, Monica, do you
Yes.
mind making your developer console font a little bit bigger so it's easier to see?
Oh, yeah.
Yeah, sorry.
I wonder, can I do that with this? Oh, yeah, I can.
Yeah, perfect.
So yeah, we just stored that as a global variable, and the browser just automatically just named it temp1. And we said temp1 get tracks because the documentation told us we could do that, and we found this array of media stream track objects. So let's look into this media stream track object that now we have access to and see what functions it has to offer. So this is the function we're after, stop. We want to stop that track. We want to stop actually, you know, there's only one in here now, but we want to stop every single track that's in there. Who knows what's there. So we need to just kind of like type out our algorithm for this, which is basically get all tracks from the stream, the microphone stream, and then stop each one. So seems like we're going to get this stream, loop through the stream, grab each track, and stop each track. We don't really have access to the stream object in here. So what I'm going to do, which will probably be useful later on, is actually make a global variable for the stream. I think I'm going to make it be a let, because I'm not sure if it's going to get rewritten over and over again. So current stream, we'll set it equal to null for now. And in here, we're going to set the global variable current, not steam, current stream to the steam to stream. So now we're actually going to have access to this object wherever we are if it's not equal to null. So we have to take care of that. If the current stream is not equal to null, then do all these steps that we want to do, because there's no point in getting all the tracks from the stream and stopping each one if the current stream hasn't even been initialized yet. So at this point in time, we're going to use this function that we used over here called getTracks to get this array. GetTracks. Let tracks equals that. Let's just take a look and make sure we're doing the right thing. We're going to log the tracks. Refreshed, enable microphone, allow, here's the stream. When we hit disable, remember we hooked up our stop microphone stream function to the disable function. So I hit disabled, and yes, we've printed out the array that we're looking for, tracks. So now we're going to need to loop over this array of tracks. Simple for loop. Get all the tracks from the stream we did. And now we're going to need to stop each one. So we can use this function that the documentation told us we could do. So tracks at I dot stop. That will stop each track. So let's test this out, because in theory, if we hit disable microphone, that means every single track in our stream, our microphone stream, will have stopped. Enabling, disabling, and notice that listening icon went away. So we've successfully we've purged all of the streams that are listening to us via the microphone. All right, so now we have turned on the microphone. You know, we've coded the functionality for ending the microphone stream, and we're gonna move on to the actual pitch checking part of this app. But for now, does anyone have any questions about the accessing the microphone stream, the API, the media devices API, or anything, or want me to go over one of these functions again?
Yeah, can we go over one more time? Yeah. For this.
You want to go over the accessing the microphone stream?
Yeah, the microphone streams. Yeah.
Perfect. Yeah. So at the start of the world, basically, right when we click the enable microphone button, we're calling this function get microphone stream. And this is the function that does it. We use the media devices API that is actually part of this whole series of web APIs that the browser has access to. So we don't actually need to bring in a library to have access to these to the navigator. It's much like the DOM in that way. So, but it's like an API. So this is a chunk of code that we mostly just copied and pasted from the media devices get user media page, documentation of the media devices API, where we basically, this is how you grab the microphone or video, your camera of your computer. Whatever stream it ends up being is you have access to within this then of the promise. And if it fails in actually getting the audio or video stream, whichever you actually provide in the constraints dictionary that looks like this, ours looks like true and then video is false, then we'll have an error and see what that error is. So we're essentially doing the same thing. Our constraints object is a global variable defined down here where, yes, actually we want to get the user media, but only the audio, and we don't want to get the video. So by the time this function completes and the user has granted access for your browser to actually listen to your microphone, then we have the stream object. So if I click block, I don't know if you saw this part of it, but if you click block, we'll enter into this catch statement, which handles the error. So we want to basically just signal the user like, hey, the microphone was blocked for some reason. We could even go as far as to even print out the error, the exact error message, why it was blocked. It would probably be redundant with this statement, but let's try it out. So I'm gonna try that again. Enable microphone, block. Yeah, so that error is not so pretty, which I assumed would be, but we can just say turning on the microphone was blocked. Not allowed, permission denied. That's pretty much what happened. I denied the permission. But if you allow it, we get access to the stream right here, and we need to be able to, after we've enabled the stream, at some point, we're not going to want this thing to keep listening to us, right? So we're going to disable the microphone, and what that function or what that button is hooked up to is this function, stop microphone stream, which takes the current stream, which is set globally here. It gets all of the tracks, audio or video, and it stops each track. So this ends up being an array of tracks, and we loop through that array and we stop each one. So when I hit disable, the listening icon goes away and we're not listening anymore. Does that clear things up?
Yeah, thank you.
Mm-hmm. Okay, so any other questions before we move on to pitch tracking and actually using this web audio API? Because we haven't even used it yet.
I don't know how to get below the website to get the console to show stuff.
The console?
Yeah, like the bottom. I don't know how to make it show.
Oh, of your browser?
Yeah.
Is there so can you see elements tab? Can you see a bunch of tabs at the top? Elements, console, sources, network?
No.
Okay. Do you see a, so you right-clicked on your browser and clicked inspect?
Mm-hmm.
And there's no bar at the top. Are there three dots on the right-hand side? Like a menu-looking thing?
Oh, yeah.
So if you click that, console should be on that list.
Oh, yeah, I got it. Thank you.
Okay, great. All right, so any other questions before we move on?
Monica, I have a pretty stupid question actually. On line 27, the stop method, did we
Mhm.
write that ourselves or is it a part of the API?
That is a part of the API, yeah.
Got it.
Because
Okay.
these tracks are this media stream track interface. So it's like this object which has all these functions. Yeah,
Oh, okay, I see it. Cool. Thank
yeah, totally. And we'll go over like all the functions we used but didn't write, and you know why did we not write them, and stuff later too. So we'll talk about all these functions as well for another time later today. All right. Okay, so I guess I'll move on to the actual to-dos for the pitch tracking part of this, which is the actual start of using the web audio API. We haven't even started yet. So we actually have a separate list of to-dos, which we talked about earlier, creating the audio context. Inside the context, create the source, which is the microphone stream. And really what we're doing is we got the microphone stream. We just need to connect it to this audio context. And then we'll do the determining of the pitch. So let's create the audio context first. So down here, we're going to declare with a let, because we're going to rewrite this audio context. And the reason why we're not, well, I'll talk about the reason why we're setting it or initializing the audio context to null down here and setting it somewhere else later. But basically, so we have to do this first step, right? Creating the audio context, the code to do that. We want to set the audio context probably after we've gotten the microphone stream, because why even bother starting the whole pitch tracking thing if we don't even have a stream to analyze, right? So I think at this point where we have our stream, we can go ahead and create the audio context, which is pretty much just audio context equals new audio context. This is a constructor that is a part of the web audio API. As you can see, there's a lot of different classes that the web audio API has created for us. And we're going to be using the audio context to make this thing happen. So we've created our new audio context here. And that's actually it in terms of creating the audio context. Really easy. It's just new audio context. So we can move on to inside the context, create the source. And let's see. So let's call this thing source. We'll probably want to initialize that down here as well. That's going to be our input node. Audio input, which is going to be our microphone stream. So we're going to set source equal to the audio context dot create media stream source, which is going to take one argument, which is the stream itself. So basically, let's create an audio source node. This function will return a node or class called, I'll show it to you just so you can see. We just use this audio context constructor, and we're just about to deal with a media stream audio source node. So this thing is what gets returned from this function. And the stream, our audio stream, is what is initializing that. So we've done this step. Inside the context, create the source. So 2 lines of code, really easy. And now the actual hard part, the determining the pitch of the microphone stream, but it's not going to be too hard because a lot of what pitch analysis is math, and that math is tried and true. And there are functions that a lot of people have written that handle the analysis of this. And we're pretty much going to set up this whole pitch tracking thing and borrow some functions that actually execute the math. So at this point in time, so let me just put these notes here too. Sorry. This is creating the audio context. This is, what did I say? Inside the context. Inside the context, create the source. And then at this point, we're kind of free to start the pitch tracking. So we're going to make a function. I'm going to delete this. We're going to create a function called start pitch track. But before we write this, any questions about setting up the audio context and why we've had to, connect the stream to this source element?
Yeah, I guess basically what does that allow us to do? Like, what is the purpose of this?
Well, so basically we need to interface with the web audio API. And to do that, we actually have to translate our microphone input stream into something that the web audio API can actually, do the analyzing for. So like, I'll show you this slide. So the workflow for the web audio API is to create this audio context constructor and create an input node that connects to an output node. And this output is your system speakers. And this input can be anything from an actual audio file to the built-in microphone for your computer. And it can also be an actual oscillator that the web audio API provides as well. So
Okay.
yeah, so we're actually just kind of doing the setup that this API requires in order for our microphone stream to like be able to be analyzed by like the cool stuff that the cool functions that web audio API has to offer in terms of like dumping audio information into big arrays to do this kind of analysis, which we'll talk about in just a second.
Okay, thank you.
All right, so, okay, so we've created the audio context, we created the source with the stream being the actual fuel for that source. And we're ready to start pitch tracking, or at least setting that up. So what we need to do is actually this step right here. This is the step we're on. We're actually, it says effects, it could be reverb, it could be panning, it could be whatever, but right now we're actually going to be doing analyzing right here as the effect, right? So we actually need to use this function called create analyzer. And we can take a look at it. Audio context create analyzer. So don't be alarmed that this is base audio context. It does seem like a different class, but it's actually an inherited class, or audio context is a class that inherits from base audio context, which means audio context is an API that borrows from the base audio context's methods and state. So they have very similar functionality, and you don't ever really interact with this thing directly. But we are going to create an analyzer node, and this analyzer node is the means of dumping all the things I'm saying into a giant array, so that we have this giant array, this buffer, as we call it, a buffer of audio information to actually analyze and compute this whole, what's the actual pitch of this thing. So we need to do a fast Fourier transform on this stuff. Don't worry, we're not gonna like get into all the math for all that, but we're just going to make a size for this analyzer node, which is you can totally dive into these class definitions. All the documentation is here. You can, it's like Wikipedia, like you can just go into a hole to like really see how this thing works, which is great. But for now, we're gonna just kind of gloss over some of these nitty-gritty details just so we can get this app working and maybe dive into it later. So you'll see that I use this create analyzer function. This would be our audio context right here. So I'm gonna go ahead and say let analyzer, actually I'm gonna go ahead and make analyzer a global function just in case. Why not? And we're gonna set its FFT size to 2048. I don't know why 2048, but that would be a whole other thing. So we also need to basically make this function happen in a way. So that buffer I was talking about, we're going to basically get time domain data. We need every single second of what we're saying to be dumped into a buffer array and constantly purged. So what we're going to need is, before we actually do that, let's go ahead and make this connection right here, where we actually connect the effects node or the analyzer node to this audio context so that it makes sense. So it's actually analyzing the stream. So we'll do analyzer dot connect. Oh, sorry, not analyzer. Source dot connect analyzer. So if you don't remember what source is, it's this audio input node, right? It's actually this guy. So what we just did is make this connection here. We made this arrow using this function, source.connect analyzer, where source is the audio input, and then, the effects node is the analyzer. So now we're going to need to execute, this chunk of code, essentially. So I'm actually going to use a different function from the get byte time domain data. Kind of want it to be a little bit more exact because our voices fluctuate so much. Or not exact because that's just too much memory. So we're going to actually call get float time domain data. And we need to pass this thing. See, Visual Studio Code already knows we need to pass this thing an array, but not just any ordinary array, but a float 32 array, which is an array that can deal with 32-bit floats. It can hold 32-bit floats. So it's a little bit of a special array. And we're going to call that array buffer. We haven't actually created that one yet, but I'd like to make it a global constant. So let's go down here and create this global array, which is a 32-bit float array. So float 32 array. And we also need to give it a buffer length. So we need to know how long this array is going to be. And we're going to go ahead and say 1024. Because it's just a recommended number. Can't say I know why. So now we've successfully, done all the things we need to do to get this float time domain data method created. So we're gonna need to actually connect this. So this is all connected to this buffer, right? So what it's going to do is it's going to dump all the analyzed audio information, the audio information it analyzed, and it's going to dump it into this buffer, this empty giant array. So we are actually ready to start using some tried and true third-party functions to do the pitch tracking itself. We're actually ready to analyze this audio buffer. So I'm going to use a function called Autocorrelate, and it takes a buffer, an empty float32 array, or not an empty one with the data in it, and it also takes a sample rate. And what it does is it spits out the frequency in hertz of the buffer at the time domain that it's at. So, you know, it probably doesn't take very long for this function to execute. And you'll notice I didn't call it from anywhere. You know, it's just, I'm just referencing this function called autocorrelate. We need to bring that in. That's something that we're going to need to bring in to our code base. So here is where we're going to bring it in. It's somebody who's written an MIT license for just pitch detection. And there's a function in here called autocorrelate, which basically determines the frequency of the audio that you're speaking or singing at a certain time domain. So we're going to copy this code, and we're going to put it in, and we're going to maybe just make a section of our JavaScript file called helper functions we didn't write. And end helper functions. And it would also probably help to throw in this GitHub repo right here for future, you know, credit and analysis. So autocorrelate, it takes a buffer and it takes a sample rate, and it determines the frequency in hertz of the buffer at a certain time domain, whichever time domain you are executing this function. So there's a little bit of black box magic trust that we have to have with this function, right? Because we didn't write it ourselves, but just kind of like getting a good idea of what it's doing roughly, and realizing that this is actually an algorithm and formula that's been repeated a lot in time. So we're going to trust it. And so we're going to spit out the frequency in hertz right here. The thing is, if we spit out the frequency in hertz right here, when we're listening to our microphone, it's only going to do it once. We need this to happen over and over and over again. So this is the concept that, this is another concept that we're going to be encountering, which is like repetitive UI and the request animation frame feature of our window, which is our browser. So we basically need this code to execute over and over and over again, which means I think I'm going to take it out and I'm going to put it in a different function. I'm going to take this out and I'm going to put it in a function called getPitch because it's a little bit more exact. And I'm going to call getPitch right here. So any questions so far on just creating the analyze node? Any questions that don't deal with like serious mathematics, because I totally can't answer those questions. But connecting the analyzer node, or like why we need to do this separately, or anything, any questions of any kind?
I have one quick question, and can you just throw the link to the GitHub in the chat?
Yes.
Oh,
yeah.
there it is. Never mind.
You got it?
Got it.
Or the GitHub
Yeah.
to, the GitHub to the autocorrelate function? Okay, you got it? Okay. Oh wait, maybe you don't have it. I don't know. Vera, did you send?
I shared the repo to the GitHub that you posted on your profile.
Oh yeah, I
Oh,
don't think
okay.
that's right.
I think
Yeah,
you need
if
a
you can
different.
share this, that would be great.
Yeah, I think you need a different one. Hold on. I can't really. Gotta stop the screen share to here. Oh, I just see I got your back on the math. All right. All right. Ask away. No, I haven't seen this chat yet, actually. So just shout it out because I can't see the chat, but shout out if you want to, talk about something or anything or ask a question.
And then did we just copy all of this?
The autocorrelate function and the two variables that are defined right above it. Yeah, just that one so far, but we're going to copy just a couple more functions from this file. So keep the GitHub open.
Awesome.
Anybody else have any questions about setting up the analyzer node and then using this autocorrelate function?
Can I see the constant variables at the bottom again?
Yes. So the new ones we made were the analyzer, and then the buffer is the new one for this little chunk.
Okay, thank you.
Mm-hmm. Anybody else? Okay, so now we're actually going to get we're going to do this repetitive UI function. We need this get pitch function to keep executing. So what we're going to do is we're going to make a request animation frame ID that's going to be null at first. And then right here, we're going to set this animation ID to window.request animation frame for the function get pitch. So what this does is basically it runs get pitch forever, or when after the first time it's called, forever, until you clear this ID. And the way we'll clear it is with another function called cancel animation frame. So before I move on to the canceling of the animation frame and when we should do that, I want to say that browsers are all different and it's really annoying, but we need to consider Firefox. And Firefox does not have the request animation frame method. It actually it has the same method, but it's by a different name. So we need to just make sure we're accounting for that by setting its real name, so WebKit request animation frame, equal to this reference to the function. And so that's kind of just like straight up just browser handling. So now we're gonna request this animation frame continuously. So let's see if this works. So we should be console logging the frequency in hertz of our voice. Ha 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 he. Oh, is this not oh, so it's at -1 continuously. -1 meaning it isn't actually tracking anything yet. So let me see. Autocorrelate, let frequency in hertz. And we have autocorrelate up here, and it's the buffer. Ah, right. Okay. Serious step. This is also something that needs to be repeated continuously. We need to keep dumping this audio data over time into this buffer. That needs to happen constantly. So that actually needs to be in this get pitch function, which will happen every second in the animation frame. So let's try that out now. He-ah, ha 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 ha. So now it's tracking my frequency of my voice, which is cool. And it says -1 when it can't detect anything. So let's disable the microphone, and then see, when I disable the microphone, we need to get this animation frame thing stopping. So now we know where to actually cancel this animation frame when we disable the microphone. So I'd say I'd put it in stop microphone stream. So it's like window.cancel animation frame, and we need to specify the actual ID of which function we wanted, or we initialized in the first place. So remember, we set this raf ID to this request animation frame. It spits out an ID. We can grab that ID and say, actually cancel that whole action. So allow and disable, and it stops. So the animation frame stops. So that's great. And now at this point, we're going to be using a couple helper functions to translate this frequency in hertz to an actual real set of notes. So we're going to use note from pitch. As you can see, this is like, you know, really, really basic, like, I mean, basic math, but not something I could definitely just whip up, you know. A tried and true equation for converting frequency to a MIDI note number. So MIDI note numbers are like 60 is C, 61 is C sharp, so on and so forth. So we're going to use this note from pitch function that we did not write. Note from pitch, and it takes a frequency which is called frequency in hertz, which is what we got right here. And this is our MIDI note. So now, at this point, now I think we should probably fill in this UI, because we have access to some of these things that we want to display. So we can go ahead and get element by ID for all these things. Note element, that's going to be like the C sharp, C. This is the hertz, so I'd call it the hertz element. We have a detune element. That's going to be the detune in cents, which we'll talk about. And then we have a detune warning, which we might not get to today, but we can work on it, or you can fill that in. So now we have access to all these HTML elements that we can now inject the HTML with. So note element dot inner HTML. So this is going to be the MIDI note. Ha, he, ha, he. So this is not really intelligible. We need to convert this to note strings. So to do that, we need an array of, you know, note strings, right? And a really interesting, easy but not readable way to actually achieve this is we got to realize that the MIDI note 60 is C, and then this is C sharp, 62 is D, so on and so forth. If you actually modulus 12 all of these, if you modulo 12 for 60, 61, and 62, oh, I kind of put this in the wrong place. So imagine that's C, C sharp, D. Then these end up equaling 0, 1, and 2, and so on and so forth, which is great because there's 12 notes, there's 12 strings, note strings that we'll have. And we can end up accessing this object, these strings, with the MIDI note by saying note strings MIDI at MIDI note modulo 12. So what that'll do is take, so this is 60 modulus 12 is 0. It's going to take the 0th element of the array and spit that back, and that's what we want. So this is actually what we want, and we need to make this happen right now in a global sense. So I'd say this is a const because these things don't really change, and gonna make these strings. Forgot D sharp. F sharp. G. G sharp. A sharp. B. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, we got it. So now our inner HTML should look a little nicer. Ha, he. And the undefined we can easily get rid of because we don't want this to be set if we notice in the console log the -1s. So if frequency in hertz is equal to -1, then we'll have to decide what to do. Otherwise, we will set the note to the right thing. And while we're here, we might as well set the frequency to, you know, frequency in hertz, and then okay, so now this looks kind of ugly, so I'm just gonna round that up. And it's probably a bit, it's a little bit cleaner now. So that's great. And now we just have to work on the detune, and you can work on the detune warning at home because, or I guess where you are right now also. So the detune is basically how off are you from like exact perfect MIDI note translation to frequency, which means we're going to grab a couple more functions. We're going to grab these two functions, sense off from pitch and frequency from note number, in order to determine that. So these two, frequency from note number, sense off from pitch. And we're going to scroll up to our helper functions area and then copy and paste these in here. So the reason why we say sense is because if you don't know what sense means, a half step in music is equal to a semitone, which is equal to 100 cents. So if you're a semitone away from something, then you're just going to be in a different note bracket. So we're going to show you how detuned you are actually in between like A and A sharp, right? Because that, you know, that's going to be less than 100 cents. Otherwise, if it was over, then you'd be over into the semitone territory. So we're going to use this function, sense off from pitch, to determine the detune. So we have our let detune equal, our frequency variable is called frequency in hertz, and our note variable is called MIDI note. And we have our detune element already initialized, so we can go ahead and set this to detune. So now you see the detune down here. And now we, you know, that's kind of unintelligible. It's kind of hard to see. So that's why I wanted to make like a detune warning thing. So like the detune warning is going to end up saying something sharp or flat. So how do we know if we're sharp or flat? If the detune, which is sense off from the pitch, is less than 0, then that means we're flat. Otherwise, we are sharp. And I'd be curious because I'm like, I don't want to just be flat or sharp. I want to know when I'm like pretty much in tune as well. So if the detune is less than 10 and it's greater than -10, that's a pretty good, pretty precise, you know, precise enough for me at least, depiction of being in tune. So we're gonna say in tune. And perhaps we want just like a little bit of color in here. So detune warning dot, we're gonna make the class actually be class flat, and we're gonna write the CSS rule for that. Flat, sharp, and in tune. So then we're gonna go to our index HTML to write out these guys. In tune, I'd say in tune you'd want to be green, sharp, red, and then flat, say blue. So now we're, you know, if it's less than 0, it's flat, and the class name is going to be flat for that element as well, so on and so forth. So now we have an idea of like if we're in tune or not, which is cool. And there's also a lot of things you can do to enhance this. But that's kind of it. That's the basic, you know, functionality to do this pitch tracking. And so yeah, the app is pretty much done. You know, you disable the microphone when you want, and it's just gonna. We can probably initialize this though if we want. So if the frequency is -1 Hertz, we can go ahead and say note element dot inner HTML equals that, and do the same thing for the Hertz, detune, and warning. Hertz element, detune element, and detune warning. Oh, is it called detune, just detune warning? I'm gonna call it detune warning element because that's way cleaner. So I know it's an HTML object. Detune warning element. Great. So now it's kind of like all initialized when he, ha, ha. Now we don't have like the note lingering. But yeah, so that's basically it. Let me just briefly just say like what you can. So basically the functions we did use, what we didn't write, we used, you know, get user media to get access to our microphone from the media devices API. We used this constructor audio context to create the audio context, and we used a couple more that I didn't include in here. And then we also used these 4 functions from this GitHub. So this is all in the deck, and you can access these. I think it'll get passed around. And the things you can do to actually enhance this are filtering. I think the best thing you can do, the first thing that you should do, is filter out super high frequencies for more accuracy, which means you need to create another effects node, because you can chain them all together, you know, the audio input node, the analyzer effects node, but in between those two, make another effects node that filters out the high frequencies to make it a little more accurate. You can also visualize your audio with WebGL, which is also on this list of web APIs. It's right here. And you can process your voice, obviously. You can make this into a vocal exercise app. You can add like a metronome or sequencing. And then also, this is kind of cool. The web audio, there's like a web audio kind of like demo portfolio list of like different things that you can do, which is exciting because, you know, we only accessed a little part of the web audio API today, and there's a lot more you can do. So that's it for me, but do you have any questions about the code? I can bring the code up again, or anything else? Anybody?
Just want to say thank you, Monica. That was a great presentation.
Will you be sharing the code after this?
Yeah,
Or-
there is a GitHub actually. I should have put that on the pitch track. Yes. Yeah, this is let me share this. So I just put it in the chat. This is an actual working example. It's slightly different than the one we just did today, but it's because we just live coded it today. But that one has all the things in it, and it's commented as well. Yeah, so you can take a look at that. And if you have any questions, feel free to email me. My email is in the presentation deck, which I think will be forwarded to everybody at the end.
Does anybody else have any other questions?
Can we also get the recorded video in the link or something?
Yes, I'm just gonna stop the recording.